All right, so our first lesson today is matrix multiplication, and example 1 piggybacks off of example 1 in your book. So let me pull that up for us real quick. All right, example 1 says a teacher assigns final grades based on a weighted system. Students are graded on unit assessments, a semester project, and the final exam, each with a different weight. The matrices given below represents the weights of each kind of work and the grades for the two students, Oscar and Reagan. So weighting, I wrote that actually in here. I wrote weighting equaled 0.50, so 50% of your grade is from your unit tests. I think is what the unit stood for. Let's see. Unit assessments, okay, yeah. 50% of your grade comes from your unit assessments. 30% of your grade comes from your semester project. And then 20% of your grade would come from the final assessment. The grades that they give us for the unit, let's see who's first because I didn't write that. Oscar made a 90 on his unit, or had an average of a 90 on his unit assessments. Reagan had an average of 80. Oscar made a 95. Reagan made a 70 on her project. And then on their final, Oscar made a 75, so this is Oscar and Reagan. And Reagan made an 85. And then they talked about the final grades for each student. So it goes on to tell you how they multiplied it all out. They took 50%, multiplied it by 90, 30, multiplied it by 95, 20%, multiplied it by 75, added it all together to get their final average. They did the same thing for Reagan. But they're saying an easier way for us to do that would be to multiply G times W, our grades times our weighting. That way we didn't have to do it individually. We could just put it in our calculator, and the calculator would tell us what the final grades were. All right, so this is how they've organized it. And it says, how could you organize the weighting and grading information differently so that their final grades are given by G times W? Well, and you guys don't have to do all this. I'm just going to show you here on my calculator just so you see this. Maybe I am. I'm going to go and input this into my matrix, into each matrix. So I'm going to edit. The first matrix is 3 columns, or 3 rows, 2 columns. And we had 90, 80, 95, 70, 75, 85. Oh, I hit the way wrong thing. That should have been an 85. Alright, so that's matrix A. And in matrix B, I've got a 1 by 3. 1 row, 3 columns. Because I've got my unit grade, my project grade, and my final grade. So now I'm going to try to multiply A times B to figure out what the final grade of Oscar and Reagan both are. And we get an error message. They say our dimensions mismatch, which when we were adding or subtracting, they had to be the exact same. That's not necessarily the case when we are multiplying, but in order for this to work, we would have to switch them. Okay? We would have to multiply, so I'm writing this over here, would need to write it. Would need to multiply W times G. Well, why do we have to do that? Because W is a 1 by 3. G is a 3 by 2. So when you are multiplying matrices, this last number here has to be the same as the first number here. Doesn't matter what that number is, but the last number in the first matrix has to be the same as the first number in the last matrix. All right, determine whether each equation may be true for the following matrices. So we're going to plug A, B, and C into our calculator. So I do want you to do this for me. So second matrix, I'm going to edit A, and it is a 2 by 2. Going to edit B. All of these are 2 by 2s. We're going to edit C. I'm going to give you a chance to get caught up real quick. Part A wants us to multiply A times B, and then multiply that by C. So let's see what that equals. So A times B and then, so that I don't have to retype this, I'm just going to say times, because that's going to bring down that matrix, times C. And this is what you should get. negative 24, 12, 4, and 48. Now we're going to multiply B times C first, and then multiply it by A. So B times C and then we're going to multiply A times our answer. Does everybody know how to get it to say A and F? You hit second and then the negative sign. And you should get the same thing. So basically they wanted to determine, was A times B times C equivalent to A times BC? Did we get the same matrix? How do I put what? A and S? You hit the blue button and then the negative symbol. So you should have got the same matrix for both of them. So what I just wrote is yes, it was true. So yes. Let's see if we can use just regular operations when we type out this next one. A plus B, so I'm going to put it in parentheses. A plus B and then was it times C? So times C. 10, 10, negative 12, negative 44. 10, 10, negative 12, negative 44. Now for A times C plus BC. Second matrix, A, C plus B, C. And did we get the same matrix? Yes, we did. So they are also equivalent. 10, negative 12, 10, negative 44. All right, the next two is actually they're showing us by hand how multiplying matrices works. So what is the product of A, B, C, D times 1, 0, 0, 1? So we're going to take A, or actually, we're going to take A times B and multiply it by 1 times 0. Then we're going to take A times B and multiply it times 0 times 1. So we got A times 1 plus B times 0. So I multiplied A times 1 and B times 0. Now for my second, so for my first row, second column, I'm going to multiply A times 0 and B times 1. All right, so now we're moving down to the second row. C times 1 plus D times 0. Then we'll have C times 0 plus D times 1. When we're dealing with numbers, it's truly just so much easier to let your calculator do this so that you don't run into a mistake somewhere. Anything times 0 we can cross out because that's just 0. A times 1 is just A, correct? B times 1 is just B. C times 1 is just C. And D times 1 is just D. So basically what this was an identity matrix. If you multiply by an identity matrix, it gives you the same thing. We'll do the same for B. A times negative 1 plus B times 0. A times 0 plus B times negative 1. Now we move to the second row. Second row, first column, C times negative 1 plus D times 0. Second row, second column, C times 0 plus D times negative 1. Anything with 0 can be canceled out. A times negative 1 is a negative A. B times negative 1 is negative B. C times negative 1 is negative C. D times negative 1 is negative D.